So what are the actually trigonometric inverse functions, and how can we be able to differentiate these functions? So that's the essence behind this video. Let's say we have a function given as f of x is equal to x minus 1. What is the inverse of this function? Now first of all, express that f of x, it is the same as y, so which means we'll have y is equal to x minus 1. Then I interchange where there is x, put y, and where there is y, put x. Now have it as x is equal to y minus 1. And then you should have to make y as the subject formula. Hence we'll have it as x plus 1 is equal to y. Now which this is the same as 2y is equal to x plus 1. Now have y being given as x plus 1 over 2. Now in this case, this is what you call actually inverse of the function, is given as x plus 1 over 2, like that. So that's the inverse of a function. So we interchange where there is x put y and where there is y put x, and make y as the subject. Let's say have f of x should be f of t is equal to, let's say, 2t minus 1 of let's say a t plus 2. What is the inverse of this function? Having f of t, it is the same as y. Now have it as y is equal to 2d minus y over t plus 2. Now we should have to interchange first, in the sense that where there is y going to put a, actually we're going to have it as t, and where there is t, we're going to have y. So have it as t is equal to y minus 1 over y plus 2. And across multiplication, you have y will give us 2y minus 1, which is equal to dy plus 2 actually t. And of which this is the same as having it as, now have it as 2y and minus dy. Just have to bring those terms with y together. You have 2d and plus 1. So now have y 2 minus d, like that, which is equal to 2d plus 1. So which means we'll have y being given as 2d plus 1 over 2 minus d. So we'll have, so which means we'll have that and as that, and that is, now let me just have to remove this one as well. And now which means we'll have it as f of t inverse will be given as 2d plus 1 over 2 minus d. Now this is the inverse of the function. Now we have a 6 trigonometric functions that you have to understand. We have, let's say, y is equal to a sine x. So what is the inverse of this function? So now principle remains the same. We have to interchange. We'll have x is equal now or sine y, and at the same time make y as the subject, in the sense that this is the same as a sine y is equal to x. So now in this case we'll have it as y is equal to a sine inverse of x, and this is true for all actually trigonometric functions. And that is, let's say we have, apart from this one, we also have, let's say, y is equal to cos inverse of the function, like that. Y is equal to the tan inverse of the function, and also have the y is equal to cot inverse of the function. It should be that. And we also have y is equal to should be sec inverse of the function. It can also be given as, let's say, a cosec inverse of the functions. So these are actually 6 it actually trigonometric inverse functions you have to understand. So that is. So now, what are the derivatives of these trigonometric functions, inverse trigonometric functions? So what are their respective actually differentiations, if that's the case? So let me just have to present you this table. We have the table for the functions, and this is the column for their respective functions. That is y, and we have the y prime there. And let's start with actually a sine inverse of a function with, let's say, input being given as u. So what is the derivative of this function? Now this one is given as u prime of now the square of 1 minus u square. So this is the actually a differentiation formula for the sine inverse. And we have cosec inverse, and with input, which is also said to be the inner function given as u. So what is the differentiation formula? We have it as negative u prime of square of 1 minus u square. And we also have also this other case, that is tan inverse. So tan inverse with inner function given as u, so I should have this. So tan inverse with inner function given as u. What is the derivative of that one? So in this case, we'll have it as the u prime of the square of, should be now just have to literally have it as now 1 plus u square. So this is the differentiation case for actually tan inverse. And we have cosec inverse. So it should be that of cosec inverse with inner function given as u. So what is the differentiation key for that one? Well, we'll have it as a negative u prime of the square of, now we should have it as u, and u square minus 1. That is the differentiation key you should have to know. And we also have this other case as well, that is now for a sec inverse. So sec inverse with the inner function given as u. What is its differentiation key? So have it as u prime of now should be u a square of u square minus 1. So that is the derivative. Mind you, here we have a negative, and that one we have it as a positive. So we'll have that and as that. So just have to memorize these actually stuffs. So we have a chord inverse of a function with input u. What is its differentiation? We'll have it as negative u prime of 1 plus should be u square. So that is. So what does it mean here? Let me go back to a sine inverse a function. Let me much specify about this one, but this is but this one will be true for all actual functions. We have, let's say we have a function y is equal, let's say, sine inverse of actually u. So what is the y prime? Now it is given as u prime of now should be the square of 1 minus u square. What is the principle behind? What it means is that what is the actually internal function, or what is the inner function of the function? We have it as u. Then what is its derivative? We have it as u prime. Then we substitute into actually this as the differentiation key. That's what is happening. Let's say we have function y is equal to, let's say, sine inverse of x squared. So now what is the derivative of this function? Now first thing, we have the inner function, which is given as the x squared. What is the u prime? We have it as 2x. And what is the differentiation key for the sine inverse? We have it as the u prime over 1 plus u squared, in the sense that now we have to substitute. We'll have the u prime, which is 2x, and that divided by now should be, well, we have it as 4 sine. Now we'll have it as u prime, actually y prime is equal u prime over, now the square of, this should be 1 minus u square, in the sense that we just have to substitute. What is the u prime? We have it as 2x, that divide by, and the 1 minus, what is the u? We have it as x squared. So now which means we have it as 1 minus, now have it as x squared and over the part 2. So which means y prime will be given as 2x divided by, now the square of 1 minus x to the power 4. That is the derivative of that one. Now what if we have also this other case? So which means you need to be very familiarize yourselves with the differentiation laws. Let's say have y is equal to a sine inverse of, let's say, sec x. So what is the derivative of this function? So now principle remains the same. What is the inner function given as u? We have it as the sec x. And what is the u prime? We have it as the sec x in the times tan x. That's the derivative of the sec x. Now what is the differentiation rule, actually, or differentiation key for the sine inverse? We have it as the u prime of, now the square of 1 minus u square. So which means the y prime will be given as, now sec x tan x, and that is divided by the square of, now should be 1 minus, now sec x, and that should be over to the part 2. So that is the derivative of that function. So that's the principle behind. So which means much of our focus has to be what is the nature of the inner function, and that the function that we have, what is the differentiation key, if it is the actually a trigonometric inverse function. So that is, what if we have this case, let's say have it as y is equal 1 over, let's say, a sine inverse of x. So what is the derivative of that one? So let me specify this one first. Having a sine inverse of x, you know, this is the same as having it as, this is the same as having it as being given as arc, should be given as arc sine x. That is the same as having this one, this is the same as that one. Or let's say a sine inverse of, let's say, x squared, this is the same as arc sine x squared. That is the same as that, in case you come across some cases like that one. So what is the derivative of this function? Now there are two ways. We can use the quotient rule, or we may have to express this one according to the laws of indices. And thereafter you should have to use the actual chain rule. Having this case, now this is the same as having it as a sine inverse of x in the overall to the power -1. That is the same as that. Of course, you should also have to try to go through that one using the quotient rule. Also have it in the same way. So which means y is given as a sine inverse of x in the overall to the power -1. So in this case, we're going to use the chain rule of differentiation, in the sense that we have y prime is equal to -1, and the inner function and over to the power negative 2 times the derivative of the inner function, and of which we'll have it as now 1 over should be the square root of 1 minus x squared. So that will be the derivative. Of course, we'll have it as now in the same way we'll have it as negative 1. Now should be negative 1. Should be negative 1. Should be negative in the terms sine of inverse to the power negative 2, and that divided by this expression. So now you can get what is happening there. So that one. And also, what if we also have this case we should have to look up to? Let's say we have a function f of x is equal to x. Now arc tan x should be arc tan square root of x. You know, having this case, it means this is the same as having it as f of x is equal to x should be now tan inverse of the square root of x. So now we have two functions, that is x as well as that one. Again, to use the product rule there, in the sense that we have f of x prime that will be given as, we may think of having it as u prime v plus v prime u. That's the way to go. Now, which means what is the u is given as the x. What is the u prime? We have it as 1. And what is the v? We have it as tan inverse of now square root of x. So what is the derivative of that one? So now this is actually a trigonometric inverse function, in the sense that we have the inner function which is given as the square root of x, actually a square root of x. Let's say the inner function has to be symbolized as, let's say, let me just have to use it to use it in the same way given as u, meaning I'll refer to this one. Don't confuse things with this u. No, it's not have u being given as x to the power half. So now which means what is the u prime? We'll have it as half x to the power negative half. Of course, this is the same as having it as 1 over 2 square root of x. That is the actually a u prime. Then what is the actually a v prime? As of pair what we are looking for. Now this case we'll have it as the v prime being given as, what is the differentiation key for the tan inverse? So now we have it as u prime over 1 plus should be u square, in the sense that we'll have it in this case now. So now which means we can have it as in this case. So have it as the v prime is equal to, now what is the u prime? We have it as 1 over 2 also square root of x, and which is also divided by, and of course we should also have it in this case as well. So let me just have to specify in this way first. So divide by now the square of 1 plus, what is the u? We have it as should be x, actually x to the actually square root of x, and of which square root of x we'll have to substitute here to the power 2. We'll have it as x. So now which means we'll have it as x. Now this is the same as having it as 1 over 2 square root of x, and divide by should be 1 plus x over 1, and of which this is the same as, now this is the same as the v prime is equal, now have it as in this case 1 over 2 root x times 1 plus x that way. Of course, you'll be able to expand that one out and substitute all these in the formula for the product rule that we presented before, upon having the u prime v prime and also having substituted the v as well as the u that we indicated before. So that is, let's say we have this case, we have y is equal to, now should be sec inverse of x squared. Let's say that's the case. So what is the derivative of this function? So now principle remains the same. This is the actually trigonometric inverse function. What is the inner function? We have it as the x squared. What is the u prime? We have it as the 2x. So what is the differentiation key and for the sec inverse? So it has to be given as the y prime is equal to u prime over u square of, now u square minus 1. Now have to substitute all these terms. So have y prime is equal to, what is the u prime? We have it as the 2x divided by, now should be x squared times the square of x squared, and over to the power 2 also have it as x to the power 4 and minus 1. So that is the derivative of that function in that case. And also, let's say we have this case as well, we should have to appreciate in the same way. For instance, let's say we have this case. We have the function given as y is equal, and that should be cosec inverse of e to the power x. Let's say that's the case. So what is the derivative of that function? So that one is the trigonometric inverse function, and that is for cosec. What is the inner function? So inner function is given as the e to the power x. And what is the u prime? We'll also have in the same way. So what is the differentiation key for the cosec inverse? We can have it as negative u prime over u square of, now should be u square minus 1. So try to substitute those terms in that one. You'll be able to have the derivative in a that pretty order. And also in the same way, let's try to go through this problem as well. And we should have to appreciate that one. Let's say we have a function y is equal to, let's say, tan inverse of, let's say, x minus the square of 1 plus x squared. So what is the derivative of this function? Now, as you can see, that's the actually trigonometric inverse function, and that is for tan inverse. So what is the inner function? We'll have it as x minus the square of 1 plus x squared. What is the u prime? We'll have this one, and this one will be done using the chain rule. Then upon having everything, we'll come back to the differentiation key for the tan inverse, and that is the same as u prime over 1 plus u squared. You'll be able to substitute all those things in that actually a formula. So that is, what if we also have, in this case, we should have to appreciate as well. Let's say we have this kind of a case. Let's say we have it as, let's say y is equal to e to the power arc. So it should be this arc sine, that should be arc sine and x to the power 2. So what is that one? Mind you, have in this case, now this is the same as y is equal to e to the power a sine inverse of the x squared. So now this is the exponential function with a base e. So y prime will be given as the same function, so that is times the derivative of the power, which is actually trigonometric inverse function. So try to have the derivative of that one as we are discussing about it. So at your own time, try to go through that one as well. That is. And also try this one as well at your own time. Let's say you have y is equal, let's say, tan inverse of x, and the overall to the power, let's say, -2. So in this case, we're going to use the chain rule. So try to go through that one at your own time. That is, the inner function is that of the trigonometric inverse function, that is for tan. And also try this one as well. Let's say you have y is equal, now arc sine, and that should be cos x, in the terms, let's say, ln sine x. So what is the derivative of this function? So now having this case, this is the same as having it as y is equal a sine inverse of cos x, in the terms ln of sine x. So we have two functions here. Product rule will be applied, in the sense that we have the sine inverse within a function given as the cos. So try to go over that one and try to understand what it means there at the end of the day. Let's say you have y is equal to, now it should be this case, we should have it as a sine inverse of, now 5 to the power x squared times the ln x. Let's say we have that case. How should we have to differentiate that function if that's the case? Now this is true more this is true more the same case where we have it as the trigonometric inverse function for sine inverse. Now we have this one as the inner function, and the inner function consists with the two functions. This is exponential function with a constant base other than e, and this is the natural function. So you are going to differentiate those using the product rule. So try to go through that one and appreciate the beauty of that question. That is. And also at your own time, try to go through this one as well. That is, y is equal to, let's say have it as ln, and I'll have it as arc, let's say arctan of x to the power 4. Let's say we have that case. How should we be able to go over that one? So this is the natural function within a function given as the trigonometric inverse function, and that is given as the tan inverse of x to the power 4. So try to go through that one. If you can still more have to remember something, but you should have to remember in that way. And should I give you more questions? Will you be able to capture those? Let's say we have this case, and of course you'll be able to have those out a proper. Let's say have y x squared, and arc should be arc sine x. So try to have that out as well at your own time. So that's how you have to understand about the derivative of actually these cases. Also at your own time, try to go through this one as well. Try to go through this one as well. Let's say have y is equal to, let's say, cot inverse of x squared, and let's say plus, now should be, let's say, cot inverse of 1 over x. Try that one. Let's say have y is equal to, now should be, let's say, cos inverse of, let's say, sine inverse of x. What is that one? So this is the cos inverse, where this one is the inner function. I understand you'll be able to capture that one out the way we're talking about GT. And finally, you should have to try this one as a y is equal to tan inverse of, now the square root of 1 minus x, and over 1 plus x. You also try this one as well at your own time. So thank you.